Hello and welcome again to physics tutorial presented to you by O3 Schools JAMB app. Your O3 Schools JAMB app is simply an application which you can install on your laptops or on your Android phones. And within this application, you have a lot of features and guides which will help you as you prepare to take your JAMB. It includes past questions, a method to try search for questions by topic so that you can try study a topic and then answer the questions which JAMB has brought out as regards that topic. There's also some information in there about the subject combination required for different courses and even schools and what courses they offer. So things like this are what you can find within the O3 Schools JAMB app. And once you download and install your app, the next thing you have to do is activate it. And the activation of this app costs 2,500 naira, and the activation is guaranteed. Simply follow the steps, and your app will be activated for you. There's no reason to be afraid that you may pay and not be activated. No, just follow the steps, and your app will be activated. Okay, so now with this, let's move on to today's class. And in this physics class, we shall be studying vectors. Now, all the quantities in physics can be broken down into fundamental and derived, yes, but also they can be broken down into scalars and vectors. Now, what are the differences? Now, scalar quantity is a quantity which is completely defined in terms of its magnitude only, while a vector quantity can only be completely defined in terms of both magnitude and direction. This means that when stating a vector, you have to state the magnitude, which is number, and you also have to state the direction for that vector for it to be complete. While scalars are complete with just the number. Also, scalars undergo arithmetic addition, but vectors undergo geometric addition, implying that when adding vectors, you must take in the direction as a consideration. You don't just say a vector of 20 plus a vector of 20 gives you 40. No, have to ask yourself, how are they directed? And vectors are represented generally in diagrams with a line having an arrow. Now, the direction in which this line is drawn gives you the direction of the vector. The length of the line helps gives you the magnitude of the vector, while this arrow here gives you the sense of action of the vector. So this is magnitude, direction, and sense of action of the vector. And that's how vectors are simply drawn. Now, whenever you have more than one vector acting on the same object, to determine what is going to happen to the object, we have to now find something known as the resultant vector. Now, what is the resultant vector? The resultant vector is that single vector which will have the same effect in both magnitude and direction as all the original vectors acting together. The original vector is one single vector which does basically the same effects, which shows up in the same exact manner as what would have happened if all the other vectors were to have been acting together. Therefore, resultant is key. Now, before I go too far, we're actually going to know some examples of vectors and scalars. Vectors include force, acceleration, weight, electric field intensity. These are just vectors. While scalars include things like work, temperature, distance. Distance is a scalar, while displacement is a vector. Time is a scalar. Electric field potential is a scalar. Impulse and momentum are vectors. So these are just vectors and scalars. So whenever you come across a quantity in physics as you move on, try to identify whether this vector is a scalar, whether this quantity is a scalar or a vector. Now, only for vectors do we look at resultants. Now, to analyze the resultant of a vector, we have to ask ourselves, first of all, like we said, how are they arranged? So, as long as we are dealing with just two vectors for now, they are usually arranged in one of four ways. Number one, parallel and in the same direction. parallel and in the same direction. In this case, we can say that the angle between them, theta, is 0 degrees. E.g., something like this, P and Q, parallel, same direction. The resultant arrow in this case is simply going to be P plus Q, and the direction will be the same direction as both P and Q. That's all. However, you can also have parallel and in opposite directions. Parallel and in opposite directions. Something like this, P this way and Q this way. And in this case, please note the angle is taken as 180 degrees. Now in this situation, your resultant becomes P minus Q. And how do we get minus? We simply take, if we take the right hand side as positive, then we'll take the left hand side as negative. Just note that the sign of my answer will now determine the direction. If I've taken right as plus and left as minus, if my answer comes out positive, then I'll know my vector is going positive. If my answer comes out negative, then I'll know it is going negative. Or in a simpler manner, just know that it's going to be in the same direction as the bigger of the vectors. So if one is 10 and one is 5, it will be in the direction of the 10 vector. Then we also have perpendicular to each other. Perpendicular to each other. Now, if the two vectors are perpendicular, that means the angle is 90 degrees. Now, a simple way to represent something like that is this. If this is P and this is Q, then the resultant is simply given by this hypotenuse or diagonal arrow, and the direction is alpha. Now, how do I get arrow? From your Pythagoras theory, we know that r equals to square root of p squared plus q squared, while alpha would be equals to the tan inverse of p over q. Now, some of you will be like, why are we using tan? Why not sine or cos? Now, the reason why is to avoid errors. P and q came in my question. So if I find tan inverse, I must be correct. However, if I was to use arrow when solving, let's say I use sine equals to p over q, or p over arrow rather, what then happens if my arrow I made a mistake when solving for it? Automatically, that will mean every other time I'm going to solve will be wrong. So it is easier to solve with those numbers that came in the question than with the other one. This is safer. So now, these are the first three types. For when theta is at 0 degrees, simply add, 180 subtract, and 90 simply apply the Pythagoras theory. Now, for the next one, we are going to look at what if it is at any other angle at all except for those three pre-specified angles. Now, if the angle changes away from 0 to 0, 90 or 180, still we have something like this. Okay, so if this is P and this is Q, if I complete this parallelogram it is forming, and I have the angle here as theta, not 90, not 0, not 180, then my resultant is gotten using something known as the parallelogram law of vectors. This law simply states that if my vectors can be represented by the adjacent sides of a parallelogram taken in order, then the diagonal drawn from the point of intersection of the two vectors gives the resultant in both magnitude and direction, implying that this is now going to be my resultant and this will be the angle of the resultant. How do I get this resultant? We apply cosine rule. Cosine rule states that r squared equals p squared plus q squared plus 2pq cos theta. Now we get a resultant. Why to get the angle, I will have to say from sine rule, sine alpha over sine alpha is facing here, so that's over P equals to sine theta over R. And this will be my formula in this situation. So now we've looked at vectors in the four different manners in which they come, and we've discovered the way to get their resultants. Now let's do one more bit of analysis. Let's say we have a force here, and instead of being at 90 degrees or 0 degrees, this force is at an angle. Think about trying to hammer a nail into the wall. This is your nail, you want to go into the wall. Ideally, you're supposed to hammer this nail like this, perfectly horizontal. But in some cases, you are either stretching to hit your nail or your nail is below and you end up hammering it at an angle. When that is done, part of your force will be pushing the nail into the wall, while part of it is going to be pushing it upwards. That means I have part going up and part going in because this force is getting shared. Such a thing is referred to as resolution of vectors. And then we should note that we can resolve vectors into both the horizontal and vertical components as long as I know the vector and the angle. Therefore, if I have a vector here P, there is a vertical component Px and the horizontal component, vertical is Py, we prefer Y for vertical, and horizontal Px. Now I have the angle here theta. Now, if my angle is here as theta, then the horizontal component is given as P equals to P. Now, instead of cramming this, because the angle can switch between here and here, how do you analyze? If I want to find Px, I'm coming down, right? As I'm coming down, that my angle is getting smaller. It is closing in the manner of speaking. This is coming here to close. In that situation, I'm going to use cos theta. So Px equals to P cos theta. While if I want to resolve for the vertical component, I'm raising this guy upwards, which is sort of opening up my angle. In that situation, Py equals to P sine theta. That's what I need to note, because if you just decide to cram the horizontal is always cos, that's not true. If you look at one like this now, for example, let's call here F, let's put theta here now, Fy, Fx. In this case, when coming to y, I'm actually going to end up closing this my angle, making it smaller. Therefore, in this case, Fy is what will naturally be F cos theta, while Fx, as I'm coming down here opening, will be F sine theta. So it is easier to remember this opening and closing and know that opening will always be sine and closing will always be cos. Okay, and now once this is established, there's one last thing we must remember about vectors before we can start looking at our O3 schools to answer past questions. And that last thing is that in vectors, occasionally you may be given more than two vectors and told to find the resultants. In that situation, what can you do? Say I have a point object here, and I have maybe three vectors acting on it. Let's never make that perfect. This is one vector P1 and that vector P2, and let's put a third vector here and call it P3. Now, each of these vectors must obviously have an angle theta 2, theta 1, theta 3. Now, in such a situation, the method of solving becomes actually quite simple. We simply have to resolve these vectors. And when we say resolve, we're going to get the horizontal component and the vertical component. Now, keep in mind, when going for the vertical component, everything that will go upwards, like these two now facing up, everything facing upwards is taken as positive, while everything facing downward is taken as negative. Then at the same time, when you go for the horizontal, everything facing the right is taken as positive, everything facing the left is taken as negative, just like a typical mathematical graph. For that reason, remember, when resolving to the vertical, up is plus, down is minus. Resolving to the horizontal, right is plus, and left is minus. So once you resolve everything, you end up getting a bunch of positive and negative vertical and horizontal. If you add up all the verticals, add up all the horizontals, you may get something like this, which, as you remember, is now vectors. So here's y and here's x, which is now vectors inclined at 90 degrees to each other and can be solved by Pythagoras theory. You see, that's a simple method we apply when in a situation like this. The only thing you should note to avoid mistakes is that, assuming I have a vector that is perfectly vertical, I don't have to resolve it. I know everything about it is vertical, and therefore the horizontal component becomes 0. Now, if I was told that up here was 10 Newton, then in the vertical part, I'm going to put 10 Newton, and horizontal, it will have a contribution of 0. While at the same time, if I had a vector that was perfectly horizontal, let's say 5, I'm going to know that in the horizontal component, I'm going to put 5. Remember that it's going left to -5. Then the vertical component is going to have an effect of 0. So just keep these key things in mind, and as you solve questions under vectors, you realize that you apply them and your solvings become quite easy. And just to show you, let's open our O3 Schools JAMB app and begin to answer simple questions. Okay, number 1 from our O3 Schools JAMB app. This one is from the year 2001, question number 8. And it's actually just theoretical. The question says, the resultant of two forces acting on an object is maximum if the angle between them is what? What makes the resultant maximum? Keep in mind, my resultant is maximum when I simply add them together. And when do I add together? When they are like this. And what's the angle here? 0 degrees. Therefore, you must note that the resultant becomes maximum as long as the angle is 0 degrees. That is option C. Very simple. Next up, we have K. Now we're going to year 2006. The component of a vector x along the direction y is what? Let's see. We have a vector, and we are told this vector is x. I want to find this component along the direction of y. And we're told that y is another vector, basically. And in this case, the component should be 0 when what happens? When x is at 45 degrees to y. If this is y, and here is 45 degrees, that will not give me 0 because I have horizontal components. If they are in opposite directions, if x is going here and y is going here, this component here is not 0, it's simply negative. So no. When they are parallel to each other, this is the parallel. No. When x is perpendicular to y, and then we can finally say yes. Because if you analyze, we just said that when we're looking at resolution of more than one vector. If this is 10 here and this is 2 here, does this 10 have any effect on this 2 horizontal? No, because it's purely vertical. Therefore, if the angle between the two forces are 90 degrees, then they have no effect on the other's direction. Therefore, my answer is D. Okay, and next up, we have a question from the year 2007, and this is question number 42. 2007, question 42. Now, for this one, we have to actually calculate quite a bit. The figure shows 4 forces. We have to find their resultants. Now, let me just draw a simplified version of it so that as I'm explaining, I can point out what I am doing. We know that here is 3 Newton, here is 10 Newton, and angle is 30 degrees. Up here is 3 root 3 Newton. And down here is 6 Newton, with the angle here being 60 degrees. Okay, we have to find resultants. Now, if you recall, we said when solving for resultants, you simply need to resolve everything to the vertical and horizontal. Let me start with horizontal, RX. Okay, let me number them to make my life quite easy. So at any time I'm dealing with anyone, we know what you're dealing with. 1, 2, 3, and 4. Let's start with number 1. 10 Newton going this way. It is to the right, so I know it's going to be positive. Now, if I'm resolving to the horizontal is down here. My angle is going to be getting close, as we can see, coming this way. So that will become 10. I mean, we close, we say is cos 30. Next up, for number 2, this is purely vertical. Does it have any effect on the horizontal component? No. So I ignore number 2. Number 3 is at 60 degrees to the horizontal. If I want to resolve horizontally, I have to bring it this way, which means my angle will again be closing. But because it is going to the left, that will be minus 6 cos 60. And then for number 4, it is purely horizontal, so I don't have to resolve. And because it's going to the right, that will be plus 3. Okay, so 10 cos 30. Cos 30 is root 3 over 3 minus 6 cos 60. Cos 60 is 1 over 2 plus 3. 2 here 1, 2 into 6 is 3. Minus 3 plus 3 is 0, which means that my resultant component is going to be 10 root 3 over 3. I'm going to leave this one first, then ask myself, what about the vertical component? Starting with 1 again. Because my horizontal is cos, obviously, without thinking, I know my vertical must be what? Sine. And it's facing up, so that will be positive 10 sine 30. Next up, number 2, purely vertical, so everything about it is vertical. That will be plus 3 root 3. Number 3 is facing down. Because it is facing down, it's going to be minus. Then, since horizontal was cos, vertical must be sine. That will be 6 sine 60. Okay, by the way, sorry, cos 30 is root 3 over 2. Let's try to avoid mistakes, please. Sorry. Root 3 over 2. And 10 over 2 here will be 5 root 3. Sorry about that mistake. Yes. Because if we get here, sine 30 is 10 times 1 over 2 plus 3 root 3. While 6 sine 60 will be 6 times root 3 over 2. 2 here is 1. 2 into 6 is 3. That will be 2 into 10, 5 plus 3 root 3 minus 3 root 3. And this minus itself is 0. So I'm left with 5 Newton. See? So I know my vertical and I know my horizontal. Now in the resultant we are solving for, they want just the magnitude and they did not ask for the direction. Therefore, I know that my resultant must be square root of arrow x squared plus arrow y squared. Okay, so arrow x is 5 root 3. 5 root 3 squared. My arrow y is just 5. 5 squared. Again, you need to know mathematics. I keep saying this. 5 squared is 25. Root 3 squared is 3. I mean, here it's going to be 25 times 3 plus 5 squared, 25. 25 times 3 is 75 plus 25. That is 100. And this will give me 10 Newton as a square root of 100. Which means that my answer is option D. So you see, the steps are very, very simple for anyone with forces like this. Simply resolve, and once you get vertical and horizontal, you can use Pythagoras theory. That was 2007, number 42, by the way. And now we move on to the year 2008, number 3. 2008, question 3. This one says the resultant of two forces, 12 Newton and 5 Newton, is 13 Newton. What's the angle between them? Forces are 12 Newton and 5 Newton. Now, obviously, if the angle was 0, they will add to each other. That's 17. No. If the angle was 180 degrees, they'll subtract. That's 7 Newton. No. But instead, I'm getting 13 Newton. Now, if you are one of those who likes mathematics a lot, you might simply remember that 12, 5, and 13 is what is referred to as a Pythagorean triple. Three numbers that can form a right angle triangle. But even if you don't, once you've tried 0 and 180, the next logical thing is to try 90. And say for 90, here will be 12, here will be 5. Let's see if we get 13. That becomes the arrow must be square root of 12 squared plus 5 squared. 12 squared is 144, 5 squared is 25. That is 169, and the square root is 13. And you see, once I try 90, my result is 13, which means that for these two to give me a result of 13, my angle must be 90 degrees. And that is all. Now, some people would have said, why did I try 45 first? I tried the different angles in order of increasing difficulty. It will be more stressful for me to try 45 and the 45 being wrong. It's easier to try the simple one 0 first. If that's wrong, try 180 first. That's that if I try 90 and it's not correct, I won't even have to bother trying to solve cosine rule because I know 45 will automatically then become my answer. So at times in examination, you have to use your brain to make these questions simpler for you and not stress yourself too much. Okay, next we are going to the year 2011 and we're going to look at question number 5. Question number 5, 2011. This one simply shows us two vectors at 90 degrees to each other and wants us to get the resultant. Because they are 90 degrees, again, I know resultant must be square root of p squared plus q squared. Now it'll be the square root of, the first one is 6, second is 8. 6 squared is 36, 8 squared is 64. Sum is 100, and square root of 100 is 10 Newton. And that is option C. So you can see very simple. Okay. Question 4 comes to us from the year 2013. 2013, number 3. The resultant of two forces is 15 Newton. I know the resultant first. Then I'm told if the forces are perpendicular to each other, perpendicular implying 90 degrees. So let's see. Let me call here F1 and F2. And I know that this resultant is 50 Newton. Okay, the forces are perpendicular and one of them makes an angle of 30 degrees with the resultant. Let's pretend that it's F2 now and it makes an angle of 30 degrees with the resultant. Find its magnitude. Once I see this, my mind should go to resolution because if these two give me the resultant, if I resolve this resultant down here, that give me F2, resolve it up here, F1. If I know that F2 should be equals to resultant, if it is coming down again, remember we are closing the angle. That will be cos theta or 30 as it is here. So F2 becomes resultant is 50 cos 30. And cos 30 is root 3 over 2. So 50 over 2 is 25 root 3. Now, instead of giving us in short form, they have their answer in decimal form. So your JAMB calculator actually can solve square roots. So you simply go there and find the square root of 3, which is 1.732, then multiply by 25 to give you 43.3 Newton. And that is option D. As you can see, when you see a question, you do not panic. Instead, you start with simple analysis of what you are told, and from there, it's very, very easy to walk your way to your answer. Okay, so we have next a purely theoretical question. This one says the pair of quantities consisting of vectors only are A, displacement and torque, B, momentum and power, C, acceleration and speed, then D, velocity and distance. Let's go from bottom up. Velocity and distance. Velocity is a vector, distance is a scalar, so no. Acceleration and speed. Acceleration vector, yes, but speed, scalar, no. Going up again, momentum and power. Momentum vector, yes. Power, scalar, no. Which means obviously my answer must be A, displacement vector, yes. And torque vector, yes. That was from the year 2005, and that was question number 1. So you see, these are quite easy. All right, then let's move on to the year 2004, question 10. Also theoretical. This one says two vectors, P and Q, the angle is 0 degrees. The vectors are said to be what? The angle is 0 degrees. Then A perpendicular, B parallel, C at angle 60, and D at angle 45. Obviously, we know for 0 and 180, the vectors are parallel. So my answer is B. This more this, you don't have to solve anything whatsoever. Okay, next question is from the year 2002, question number 9. And for this one, yes, we are actually solving. Two forces, each of 10 Newton, acts on the body. One towards the north and the other towards the east. And you should please know your coordinate system. We refer to north as being upwards and east generally to the right. Alright, so they are both 10 Newton, 10 Newton. But to find the magnitude and direction of the resultant. Now, resultant will be square root of 10 squared plus 10 squared. That will be 100 plus 100, which is square root of 200, which if you are familiar with short form, like it should be, you know will be 10 root 2 and nothing. However, for the direction, you never have to solve. Obviously, if one is going to the north, the other is going to the east, my answer must be somewhere northeast, between the north and the east, which indicates automatically that my answer is D at 45 degrees, 45 degrees east of north. And that is my resultant. So you see, just follow your steps, don't jump, and you will always get your answer. Okay, next up, okay, and now let's take one last question under this topic. And this question is brought to us from the year 2004, and it is question number 18. 2004, question 18. Now we have a diagram. Let's draw it so that when we're analyzing, we can all look at it and I can indicate it on the board. We have a force of 8, yes, 10, yes, 8, yes, 8, both at 60 degrees, 60 degrees, and this way we have a force of 4 Newton. We have been asked to find the net horizontal force. They don't want us to find the total resultants, just the horizontal components. So how do I go about that? As I'm aware, arrow x will be, let's number again for simplicity case, 1, 2, 3, 4. And as you are aware, out of my 4 vectors, 3 of them are facing the right, which is positive as we know, and only one is facing the left, which is what? Negative. So let's start with number 1. This is 8 Newton and go is 60. I'm resolving to the horizontal. I'm coming down here, closing my angle effectively. Therefore, that will be 8 cos 60 plus my 10 Newton is purely horizontal, number 2. No need to resolve anything there. That will be 10. This other 8 down is experiencing the exact same thing in the horizontal sense at least as this 8 up. That will also be 8 cos 60. Then 4 here purely horizontal, but to the left, so minus 4. Now cos 60 is 1 over 2, so this becomes 8 times 1 over 2 plus 10 plus 8 times 1 over 2 minus 4. 8 times 1 over 2 obviously will give me 4 plus 10 plus 4 minus 4. 4 plus 10 is 14. 14 plus 4 is 18. Minus 4 again is 14. And now, as I finish this, I realize one funny thing. My answer is not in my options. What could we have done wrong? This is part of those things where you have to be careful. And if I look at my question carefully, I realize that my bottom force isn't 8, but actually 6. Just because the angles were the same and the question was looking perfectly symmetrical, I assumed without thinking carefully that this was 8 rather than 6, which means I have to correct that value and make it 6. Now, once you identify a mistake, you know how to clean your solving entirely. Simply find the place where you use the wrong value and try and correct it if that will make your work easier. Like here, I know instead of 8, I should have had 6. I should have had 6, which means here, instead of 4, I should be having 3. And then 4 plus 10 is 14, plus 3 is 17, minus 4 is 13 Newton. And now, yes, that is my options. Option D. So now the purpose with number 6 was to show you what happens when you make a mistake. That you don't have to panic and run and think, no, 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 I'm wrong or clean everything. No. Carefully check your question, identify this mistake, and ask yourself, can I easily correct it? Mine was easier because I only solved with that value once. If I have solved with that value maybe 7 or 8 times, then it might be fast to start over. But in this case, it definitely was not. So that is what you should actually calmly and rationally check and follow whatever steps feel appropriate next rather than panicking. Okay, and with that, we've come to an end of this class on vectors. I would like to thank you very much for watching. Please subscribe to this channel so that you can see more videos on different topics and different subjects, not just physics. You also get instructions on other subjects as well as information. And also remember, activate your O3 Schools JAMB app. My name is Athanasius, and thank you very much for watching.